In this video, we clean install macOS Catalina public beta on Windows 10 using VirtualBox. Hello everyone and welcome to TechFixFlix. In this tutorial, we will create an installation ISO of macOS Catalina public beta, then transfer that ISO to Windows as the basis of a virtual machine in VirtualBox. In earlier videos in this series, we've performed clean installations of both High Sierra and Mojave, and this video follows that tradition, inheriting both the benefits and challenges of this method. As ours is a clean installation, we will create our own installation media, then deploy it to a virtual Mac, and we prefer this method to simply downloading pre-created hard disk images from the internet, in which we relinquish control over what may be installed on that image with all the security implications which follow. The path ahead is not necessarily straightforward, and we will need to download a full Catalina Beta installer, possibly on an unsupported or virtual Mac, with the aid of a third-party utility. Then we need to convert that installer using commands entered in terminal to an ISO format to maintain compatibility with the Windows version of VirtualBox, before transferring the large ISO file to our Windows host. Thereafter, we need to create and configure the virtual machine, before adding extra data using an elevated command prompt. We then install the Catalina Beta, but to use it, we need to initialize an otherwise hidden hard drive, break a boot loop, and add APFS support. Thankfully, none of these steps are particularly difficult, and we'll walk you through each of them. Finally, if you're watching this video after the mainstream release of Catalina, or beyond, it's entirely possible that an updated version of this video will have been posted on our channel, mirroring the latest release. We begin on our Mac desktop, and that can be either a physical Mac or a virtual one of the type created in our previous tutorials. As before, we only need the Mac for an hour or less to download and package the installer. We need to download the full-size Catalina Beta installer, which is heading towards 7 GB in size, and we obtain this with the assistance of a third-party download utility, which not only obtains the full installer, bypassing the need to register for beta schemes or log into the Mac App Store, but also has the advantage of working on unsupported Macs. We therefore head to the link shown on screen now and in the written description accompanying this video. Whilst the use of a third-party tool runs somewhat contrary to our clean installation philosophy, this utility simply connects directly to Apple's servers to perform the download. Clicking on the download link takes us to a Google Drive storage space, where we click the link to download. The initial download is merely the Patcher Tool, weighing in at 185 MB. In Safari, we are advised that the file is too large for a virus scan, and we exercise the option to download anyway. Our download begins, and once complete, we tick to run it. The DMG opens, revealing the macOS Catalina Patcher utility contained within, which we run. As the software is from an unidentified developer, the system flags this as a potential risk. We therefore acknowledge the message and head to System Preferences, where we open Security and Privacy, within which we select the option to open anyway. A further message queries our intention, and we click to confirm our instruction to open. The Patcher application now opens, and we click to continue, further clicking to progress beyond the credit screen. As we're looking to download a copy from the server, we naturally select the option on the right. We are advised that the download is a sizable one, and we click to commence. The download begins, and we can take a short break as it progresses. Upon completion, we are presented with the installation method screen, and our hopes were briefly raised by the presence of an option labelled Create an ISO image, tantalisingly greyed out. We don't know whether this was specific to our hardware configuration, or whether this is a planned future feature, but this could potentially save us a considerable amount of work in future. For now, however, our methods remain old school, and we therefore simply exit the app. The full installer appears in our Downloads folder, and we close the app, ejecting the DMG and deleting it. As the Patcher app defaults to our Downloads folder, and our commands presume that the installer is located in our Applications directory, we move the installer to the Applications folder to ensure smooth passage through the next phase. Whilst within our Applications folder, we search for Terminal and run it. With Terminal running, we close the remaining window. We can now enter our commands. There are 5 to input, with Enter pressed after each line. As always, we've reproduced these commands in the written description, allowing you to simply cut and paste. As ever, we are not the authors of these commands, and we wish to give credit and thanks to their original sources and authors, as linked in the description. The first command creates a blank temporary DMG file. The second command mounts the image, and we see the virtual disk in the upper right. Our next command adds the installation media, but not before requesting a password. This is simply the master password used to log onto the machine at the start of any session, followed by the enter key. It's input invisibly, and therefore there will be no confirmation of your keystrokes. Although the system warns of erased volumes, this is simply the blank volume we've created, and the remainder of the system will be unaffected. We therefore type Y to confirm. The erasing phase begins, followed by a phase of copying, after which the disk is now made bootable. To work upon it further, we need to eject it, and having selected it, we right-click and select the option to eject. With the disk ejected, we return to terminal and enter the final two commands. The fourth command creates a DMG in our downloads folder, taking a few moments to process, whilst the fifth command converts that DMG to an ISO, and this is the ISO which we'll transfer to our Windows machine. We close the terminal window and open Finder, where our ISO named Catalina resides. You can now transfer this file to Windows by whatever means you choose. We arrive on Windows with VirtualBox installed and running. In the event that you require an overview of this process, we've created a tutorial covering the basics of VirtualBox installation, linked in the written description. We now need to create the virtual hardware upon which our Catalina installation will run. We click Machine, dropping down to New. We provide a name. Although we have entirely free choice here, the name we provide will need to be referenced in the commands we enter at the command prompt later in the tutorial. We therefore opt for the very literal Catalina. If you choose a different name, you'll need to modify the commands provided to reference the name you've chosen. Having named our machine, we click the Type drop-down, identifying our machine as one using macOS 10. As we're running on a 64-bit host, we also click the version drop-down, moving away from the default to reflect that 64-bit architecture. With our basic details confirmed, we click Next to continue. We increase the minimum recommended RAM from the default 2GB, and we allocate 8 from the 64 we have available. As ever, we recommend using even multiples of 1024 MB, leaving sufficient RAM for the operation of your host machine. Having allocated our RAM, we can accept the default for the next three options, and we therefore create a virtual hard disk now of the VDI type with a dynamically allocated hard disk file. The amount of storage space will be dictated by the amount of physical storage you can allocate and the extent to which you intend to install apps on the virtual Mac. As we are purely demonstrating, we allocate a very modest 30GB, although were we intending to use this VM more seriously, we would provide significantly more storage. We click Create and our machine is created. We now need to configure the virtual hardware. We therefore right-click the newly created machine and select Settings. There are a number of settings to adjust, and we move from General to System, where we deselect the floppy drive, long ago obsolete on macOS. A crucial change which we must make is to increase the number of processes from the default 1 to 2, and note that the virtual machine will fail to start if this setting remains unchanged. We move to our display options, increasing video memory from the default 16 MB to the maximum 128 MB. Finally, we move to storage, where we will insert the ISO file we've created on the Mac as a virtual optical disk file. We click the empty drive, then the drop-down in the upper right. We select the option to choose virtual optical disk file before navigating to the location where we transferred our ISO. We select the ISO and open it, attaching it as a virtual disk from which our machine can boot. We're almost ready to run the virtual machine, but prior to doing that, we need to add some supporting lines of code using an elevated command prompt. We therefore click our Start button and type CMD, moving to the right pane and selecting the option to run as administrator. We then click Yes where queried by user account control. The command prompt appears. Our first command changes the Active Directory to our VirtualBox installation folder. If, like us, you use a custom installation path, you'll need to modify this command to reflect the true location of your VirtualBox installation folder. Note that this is the only command in this phase which is visually confirmed, with the remainder acting silently. We now enter the next 6 commands in sequence, hitting enter after each. As always, copies of these commands are located in the written description from where you can cut and paste. Remember that if you haven't followed us and named your machine Catalina, you'll need to amend each of these commands to reflect this. As before, we are not the authors of these commands, and again, links to the original sources are provided in the description, and they are required to ensure that the virtual machine functions as intended. An additional command determines the screen resolution of the virtual machine, and you can amend the final values to better suit your display. In this example, we run at 1920 by 1080 simply to match the format of this video. With the commands entered, we exit the command prompt and return to VirtualBox. We can now launch our virtual machine. Throughout the remainder of this tutorial, we will see many screens of white text on a black background. There are two key rules. 1. Don't be alarmed by anything you may read in terms of errors, missing files or resources. Reading the text will undermine your confidence in the installation. 2. Be patient. As long as the text keeps scrolling and your drive activity indicators keep flashing, your installation is on track. Your patience will be rewarded when the Apple logo appears, and once the initial progress bar is completed and the screen darkens, it's time to enter some basic configuration, and we drop down to localize our language to UK English. Incidentally, if at any point in the process your keyboard and mouse become unresponsive within the virtual machine, we cover the method to enable them at the end of the tutorial. We arrive at the macOS Utilities menu. Previous videos in this series have shown that immediately clicking Install macOS will not yield a successful installation, as the main hard drive must first be initialized. We therefore select Disk Utility before clicking to continue. At the Disk Utility screen, we will make our VBox hard disk media drive available to receive the installation. We select it and note immediately that it's uninitialized. We therefore click Erase, prompting the appearance of this dialog, at which we change the name of the disk from Untitled to the more familiar Macintosh HD. This is the only change we will make to the settings before clicking Erase. The disk will then erase, after which it's ready for the installation. We click Done, then exit Disk Utility, returning to the macOS Utilities menu. From here, we can now select Install macOS. At the first screen, we simply click to continue. Thereafter, we click to show compliance with the relevant software license agreement, and we are required to agree a second time from the drop-down. The drive we labelled Macintosh HD is available for the installation, and we therefore select it before clicking Install. A brief installation follows before we return to more white text. If we take no further action here, we will be stuck in a loop, which will unhelpfully take us right back to macOS Utilities. We therefore close down the virtual machine at any point from the appearance of the white text onward, selecting the option to power off. To break this loop, we need to eject the installation ISO and instruct the virtual machine to boot from the hard drive. We proceed by returning to VirtualBox, right-clicking our virtual machine and selecting Settings. We navigate from the General Settings dialog to Storage, where we select the Catalina installation ISO, click the drop-down and remove disk from virtual drive. With that, our virtual disk is empty. We can now rerun our virtual machine, although progress is minimal as we are thrown into the EFI shell. After the 5-second countdown, we type exit at the shell prompt and press enter. Again, should your keyboard not respond, we'll address this toward the end of the video. We enter this menu, which is navigated using arrow keys, with options selected by pressing enter. We therefore use the down arrow to select the Boot Maintenance Manager option. Pressing enter takes us into the Boot Maintenance Manager. We drop down to select Boot from File, where we again drop down, selecting the lower of the two files. From here, we select macOS Install Data, again hitting enter on the only option labelled Locked Files. We again have only one option, Boot Files, at the next screen, which takes us to the final screen, at which we drop down and run Boot EFI. Selecting that option propels us back into a field of text, after which we again see the Apple logo. The screen darkens, ahead of the second, longer installation phase, during which we can take a break. Following the restart, we are returned to the EFI shell. As we can progress no further without APFS support, it's once again time to close the virtual machine, powering down to allow us to add another virtual optical disk. Returning to VirtualBox, we right-click our virtual machine and select Settings, again navigating to Storage. We select the now empty virtual optical drive, click the drop-down, selecting Choose Virtual Optical Disk File. Then we navigate to the TechBlocker's APFS ISO, downloading from the link shown on screen now and in the written description. With the ISO selected, we now open it, once again attaching it to the virtual optical drive. With the disk attached, we rerun the virtual machine. Our first objective is to make sure that we don't need to keep the ISO permanently attached purely for the 3 files it contains, and it's far more sensible to copy them to the main hard drive. You will note that the EFI shell maps our hard drive as FS0 and our optical drive as FS1. We therefore type fs0 : and hit enter. This gives focus to fs0, our primary hard drive. This is the anchor for our second command. We type copy -r fs1 : /EFI. This will copy the directory EFI and its content from our optical drive fs1 to our hard drive fs0. Incidentally, the / on a Mac guest maps to the hashtag key immediately above right shift on our UK English Windows keyboard layout. We now see confirmation that the 3 files have copied. If you see anything other than this confirmation, you'll need to correct this as the installation cannot proceed in the absence of APFS support. We now need to edit the startup file to load these 3 resources at startup. We therefore type edit startup.nsh and hit enter. We are taken to a blank editing window. Unlike our previous command entry, this is more akin to a text editor, and the commands will not be run until the file is saved and run. Again, press enter after each line, although note that we can freely move around the document with the arrow keys. We issue an echo off command to suppress the output of these commands. Then we type 3 commands, each of which launches a resource required for APFS support from their new location on fs0 where we've just copied them. We then issue a map command, which remaps the drives to take into account the newly discovered APFS volumes. Then, we change focus to fs3, which should be the APFS volume on which our installer is located. There is a weakness in our method here, as the mapping command will assign to fs2 or fs3, so should the boot fail, we will need to return to the startup file and substitute fs3 for fs2. Again, if anyone can resolve this, we'd love to hear from you. For now, we revert to fs3. Within fs3, we change the directory to System, Library, Services, and we run the boot EFI file therein. With our file modified, we press Ctrl-Q, then Y to confirm our save request. We return to the EFI shell, and we type exit, then hit continue. The countdown begins, and if you're fortunate, you'll boot all the way to macOS. We weren't as fortunate, but at least we know why, as fs3 was not found, thereby halting the installation in its tracks. We therefore return to fs0 by typing fs0 : then hitting enter, and retype edit startup.nsh before hitting enter again. Once within our startup file, we substitute fs3 for fs2 before again pressing Ctrl-Q and Y to save the changes. Presently, we are alternating between fs3 and fs2 and are looking for a more permanent solution. Be aware of this when you run your virtual Mac on subsequent occasions. Back at the prompt, we type exit, then hit continue, and our installation sparks back into life, with a further final flurry of white text. Again, be patient, look for drive light indicators, and the continuous scrolling of text. The screen darkens, and we are into the final phase of personalization. From here, it's very straightforward, and your configuration changes are of course a matter of choice for you, and we show ours purely for completeness. We drop down to localize to the United Kingdom, where helpfully the most likely preferred language, keyboard and dictation options are preset. We can therefore click continue, and we also continue at the data and privacy screen. As we're purely experimenting, we decline the option to transfer data from elsewhere. We also choose not to sign in with our Apple ID, choosing instead to set up later. The system queries this, and we confirm our intention to skip. We still haven't ever read the terms and conditions. We're pretty sure that somewhere in there they will frown upon us extracting their OS to use in a VM on Windows, but as we haven't read that yet, we don't know for certain. Making matters worse, we have to compound the lie by clicking agree at the drop-down. As we haven't signed in, we create a local account, selecting an image which best represents us, and what suggests stereotypical British male more succinctly than a football. That's better. We enter our full name, which automatically populates the account name field. We then enter our password, with a second entry required for confirmation. If we really want to, we can enter a password hint before clicking continue. We choose to customize our settings at the Express setup screen. We opt not to enable location services and are again required to confirm this via drop-down. Time zone can be selected by clicking on the map, selecting from the drop-down, or by typing directly in the box. Transmission of diagnostic data is enabled by default in beta versions, so be sure to disable that in security and privacy if this is your preference. Screen time configuration is new to this setup, but we thoroughly disapprove of anything which limits our access to tech, so we'll definitely be clicking Setup Later here, and by later, we of course mean never. There are now 3 options under Choose Your Look, and we'll be staying on the light side. After a final setup phase, we glimpse our somewhat obscured Catalina desktop. We close the feedback assistant, leaving us the simple task of keyboard setup. After clicking Continue, we are simply required to press the key to the right of left shift. With our keyboard identified, we simply click Done. As a last task, we can safely eject the APFS ISO with its content now copied onto our hard drive and incorporated into our boot sequence. We right-click the virtual disk and select the option to eject. With that, we gain our first unobstructed view of the Catalina desktop running under Windows. We now return to keyboard and mouse support. To ensure that they function in a Mac guest, you will almost certainly need the VirtualBox extension pack, downloadable from the link shown on screen now and in the written description accompanying this video. Click the All Supported Platforms link to begin the download, which is quite small at just over 22 megabytes. Returning to the main VirtualBox interface, we click File, then Preferences, and at the Preferences screen, we navigate to Extensions, clicking on the plus icon in the upper right. At the selection panel, we navigate to our downloaded extension pack and open it. We click Install to confirm our intention, then scroll through the license terms. Once fully scrolled, the option to agree is enabled, and clicking it installs the extension pack. With the pack installed, keyboard and mouse should be enabled in our virtual Mac. Thank you for watching this tutorial. Hopefully you found it useful. If you can provide a better, faster or more economical solution, let us know in the comments. We'd love to hear from you. If you'd like more, you are very welcome to subscribe to the TechFixFlix YouTube channel by clicking on the subscribe button. Subscription is of course entirely free and provides easy access to all of the videos posted here. Clicking on the neighbouring bell icon means you will be notified whenever a new video is posted. You can also keep in touch by following the official TechFixFlix Twitter account. Until your next TechFix, goodbye.